So look at the statements. All books are tables, all books are chairs, no copies are chairs, and all chairs are stools. So draw the basic diagram first, right? Draw the basic diagram. Yeah. So all books are tables, all the books are tables. Let's say these are books, all the books are tables, all the books are tables. Okay, now he says all books are chairs. Now in such cases, there is a problem, right? There are two different possible basic diagrams. You getting it? There are two different basic diagrams. He says all books are tables and all books are chairs also. So either you can say chairs and tables are equal. That's one way of looking at it. Or you can see chairs overlapping tables, or the other way to do it is as follows. All books are chairs first and then tables. See, both are same. I mean, both are same as in with respect to chairs and tables, there is a difference here. But we have not violated any of the statements in both the cases. All books are tables, all the books are tables, and all the books are chairs. All the books are inside chairs. Here, all the books are chairs and all the books are tables. The only difference is in the first case, chairs are overlapping tables, or tables are completely inside chairs. In the second case, chairs are completely inside tables. There's one more way of drawing the diagram. You can take both chairs and tables equal. That also can be done. Both chairs and tables can be made equal. Yeah, but then that will not be the basic diagram. Basic diagram means minimum overlapping. So if both of them are overlapping completely, then that's not minimum overlapping, right? Here, at least some chairs are outside. Here, at least some tables are outside. So let's take both the diagrams. Okay. Next, no copies are chairs. No copies are chairs. So copies and chairs should not overlap. Let's say copies are here. No copies are chairs. Here also copies and chairs should not overlap. So basic, both are basic. It's not possible. Both are basic diagram, right? Copies and chairs should not overlap. Copies and chairs should not overlap. So here you see chairs is outside. So these two cannot overlap. Chairs is inside, but still copies and chairs cannot overlap. And the last one, all chairs are stools. All chairs are stools. All the chairs are stools. All the chairs are stools. Okay. So how will you draw? Look at this very carefully. All the chairs are stools. For the first case, stools will completely overlap chairs. So hence stools will overlap books and tables. In the second case, he says all the chairs are stools. Now I can draw stools outside, but that will not be basic. For the stools to be basic, I should take only overlapping with chairs and not with tables. You getting it? You're able to follow. All the chairs are stools. So I need not draw a bigger circle here. I'll draw a circle in such a way that only chairs are stools. I can avoid some of the tables. So that's the difference. You're getting me? Looks like a simple basic diagram, but there are two possibilities. All books are tables. All books are tables. All books are chairs. All books are chairs. Here all books are chairs. No copies are chairs. Chairs and copies are not overlapping, and all chairs are stools. Here all chairs. Chair was the external, outermost circle. We have, uncovered that with stools. Here chair was not the outermost circle. We have drawn one circle just between chairs and tables. So be very careful, right, when you're doing this. Now look at the conclusions. Some copies are tables. And remember, for a conclusion to be true, it should satisfy both the diagrams. Only then you can take it as true. Conclusion is true if and only if it satisfies all the diagrams. Basic diagram as well as the possible diagrams. Here basic itself, we have got two possible cases. For basic itself, there are two ways to do it. Yeah. So for a conclusion to be true, it should satisfy definitely these two diagrams and also the possible diagrams. The first conclusion, some copies are tables. Some copies are tables. False. In the basic diagram itself, it fails. Copies and tables do not overlap at all. Here copies and here tables. Are they overlapping? No. So some copies are tables is false. All books are stools. Are all the books stools? Yes. If you look at first diagram, all books are stools. Even if you look at the second diagram, all the books are stools. Irrespective of whether you take chairs outside or tables outside, books are always completely inside stools. In any possible diagram you draw, books will always be inside stools. Why is it so simple? All books are, you need not even look at the diagram for this one. All books are chairs. All chairs are stools, right? When you have all A's are B's, wherever you have chairs, you can replace that with stools. When you know all chairs are stools, wherever you have chairs, those can be replaced with stools. So what happens? All books are chairs will become all books are stools. So all books are stools is a correct conclusion. No doubt about it. Third conclusion. Some stools are not tables. Some stools are not tables. True. If you look at this basic diagram, these outside stools are not tables. You see, some stools are not tables. I mean, let me use a highlighter so that you can understand this easily. Yeah. Sorry. Let me show it using a color coding, right? Some stools are not tables. We are looking at this green region. Some stools are not tables. Yes, if you look at the first basic diagram, these outside stools are not tables. This is the region. These outside stools are not tables. True? Yes or no? But in the second diagram, all the stools are tables. In the second diagram, if you see all the stools are inside tables. When all the stools are inside tables, how can you say some stools are not tables? Which stool is not table here? All the stools are inside tables. You getting it? So while this third conclusion, some stools are not tables, satisfies the first basic diagram, it fails in the second basic diagram. Right here, you see all the stools are inside tables. So when all the stools are inside tables, you cannot say some stools are not tables. So this is wrong. Definitely wrong. Yes or no? Fourth conclusion, all tables are stools. Yes, again if you look at the basic diagram, all tables are stools, the first one. In the first basic diagram. In the second diagram, all tables are stools? No. Some tables are not stools. Only some of the tables are stools. Outside tables are not stools. So this is false. This is false. You getting it? Now let me use a highlighter for the second diagram also, fourth conclusion also. What happens you see? Sorry. What does it say? All tables are stools. If I look at the first case, all the tables are stools. Yes? All the tables. You see, all these tables are stools, inside stools. But in the second case, not all the tables are stools. Some tables are outside. So the point is, I mean, let's actually do it carefully. What I would do is, let me call it basic 1 and basic 2. Now look at these conclusions individually, right? Third and fourth one. Third conclusion, conclusion 3. Third conclusion and the fourth conclusion. Yeah. What are the two cases? Basic 1 and basic 2. Check this properly. What happened to third conclusion? Some stools are not tables. In basic 1, yes, it satisfied. Some stools are not tables, outside stools. But it failed in basic 2. Some stools are not tables, fails because all the stools are inside tables. Conclusion 4. All tables are stools. All tables are stools, satisfied. All tables are stools, satisfied here because tables were inside stools. All tables are stools. You see, all the tables are stools. Satisfied or not? All tables are stools. But all tables are stools did not satisfy in the basic 2 diagram. You getting it? Now, if you are trying to say that 3 and 4 makes a complementary pair, you are wrong. Because what is a complementary pair? Complementary pair means if third one is correct, fourth one should be wrong. If fourth one is correct, third one should be wrong. Here what you find is both third and fourth are correct in basic 1 and wrong in basic 2. Hence, it cannot make a complementary pair. It would have made a complementary pair if this is correct and this is wrong, and this is wrong and this is correct. Only one of them has to be correct. Here either both are correct or both are wrong. See, it all depends on which is outside. Is table outside stools or stools outside tables? Yes or no? From this one, what do you see? These are tables and here we have stools. Here in the second one, what do we see? Only look at stools and tables. No, stools are inside tables. In the first case, tables are inside stools. In the second case, stools are inside tables. So when you say some stools are not tables, first one satisfies. Second one fails. When you say all tables are stools, yes, satisfies here, but it fails in the second one. So both of them are either correct or both of them are wrong, which means none of them is always correct or, none of them is always correct or always wrong. This is correct sometimes, this is also correct sometimes. But conclusions have to be definitely true, right? A conclusion is definitely true if and only if it satisfies all the diagrams. These conclusions fail, both these conclusions fail if I take tables outside stools, which is a possible case. Hence, the overall answer to this question should be only 2 follows. Only conclusion 2 is true. First one is definitely wrong. Second one is definitely correct. Third and fourth are definitely wrong. So your overall answer to this question should be only 2 follows. You getting me? So only 2 follows. My handwriting is not as bad as it appears here. Let me just rewrite. Only 2 follows. Yeah, answer is only 2 follows. Any diagram you consider, you will find that only 2 follows is the correct one. Others are all wrong. Maybe right, maybe wrong, but they're not definitely right. So the final answer to this question posted by Sneha is only 2 follows. Okay, only 2 follows.